All right. So now in this, I think this is number 66. At this stage, we're ready to get into the trig part of the problem. We've got all this set up. You know the angle measures and all that good stuff, or at least you know that they are in radians are all the same, and they're all each of these pieces. Do I have my pointer? I don't know. I'm hoping the pointer shows up. Each of these pieces here is pi over 8 in radians, and we're working in radians and all the other good stuff. So let's start knocking out the problem. It's not going to be fast, it's going to be smooth. And I'm going to go slowly through it still. So don't get frustrated if you feel like you're moving too slow, or don't get mad if this is not the perfect speed for you. Okay, you're welcome to pause this as needed. You're welcome to like watch a different part. No, stuff, and I might be going too slow. I'm going to try to not skip any steps while also not insulting your intelligence. We're going to see if I can find that balance. I might not be able to. All right, so that's still the same problem. The 66, he cut this arc into 4 equal pieces based off of the arc length, right? He wanted the curved pieces to be the same length all the way through. The radius is 10 feet the whole time. I don't think I put in my units and my numbers in here, so I'm going to keep emphasizing them orally. All right, so the radius is 10 feet, right? That means that throughout this circle in all the different places, from this edge out to the curve is 10 feet everywhere. All of these lines here are 10 feet, okay? That also means that first section of A that was labeled A is some distance, plus that next section, plus that next section, plus that last section, all equals 10 feet combined. They're not each 10 feet. They're not even each the same. All right. So we're going to use, it said Alicia, I think is the person, eventually saw, hey, we can do this problem with trigonometry and it'll actually be right, which is the most important part. And smooth, which does not always mean fast. It just means, oh, I won't have to sit here and really ponder it. It'll be orderly, one thing after the other. So I'm going to go straight to it. First thing is, if you hear the word trig at any point in time, you need to think triangles. The word trig comes from triangles. And we're going to look at this. We're going to go, by the way, we're going to work this problem right to left. You can work the problem left to right. Your triangles are going to look different. Or technically, I guess you could do it doing it the same way, just going opposite order. So really, you can go either way. I'm going to build it right to left because the angles are smaller and work that way, but it's also because that's the way I drew it. So there's dozens of ways you can do all of these problems. We're going to do it the trig way because that's what chapter we're in. We're going to go right to left because that's the order I drew them. But don't be frustrated if you looked at it a different way. You should be thankful that you looked at it a different way because that means you're special, you're different, or that just means, hey, you have another solution. You have your method of getting to the solution, and you have mine that I'm giving you, which means you now have 2 ways, and that's twice as good as someone that was just getting mine. All right, enough rambling. So I have this gray triangle. That's that first piece. Notice it makes a right angle right here, which is beautiful, and it kind of isolates this D thing here, this D section, that last section, right? So I can now look at this right triangle. We want all of this space at the bottom so we can take it away from 10, right? So we can just see what that little leftover stuff is. So that's why if I want this bottom, this side that's next to this angle, which is pi over 8, all right, that's why I'm going to grab cosine. If you did something with sine, you probably use the triangles on the opposite side going up and down. Okay, you can do it with any of the trig functions. And I said that tangent's probably going to be the hardest one to do it with, but you can when we can get you there. Don't ask me in class to do it with tangent because we would then spend a lot more steps, more time to get there. Not saying we can't. I'm just saying we're not necessarily ahead to where we could spend a day doing it a different way just because. All right, so here's cosine. All right, that's the adjacent over the hypotenuse because it's so ka toa, right? So its cosine is adjacent over hypotenuse. In this case, our adjacent is sides A plus B plus C. That's the whole adjacent side, right? And the hypotenuse is 10 because that's the hypotenuse happens to be a radius. Notice I color coded this thing. I'm going to color code them the whole way through. The adjacent side is going to be red the whole way through. The hypotenuse will be blue, and theta, our angle, will be green this entire time. Now, what I want is this length so I can take it away from 10, right? Or actually, I don't know. Yeah, we'll do that eventually. All right, now, if I want that length, I can multiply both sides by 10, right? Now 10 times the cosine of theta is that adjacent side. If you heard me in class Thursday and I was talking about how I always think of sine as being the height and cosine being how far I've traveled, that's always true if the radius is 1. The radius being this part of my hand, right? The hypotenuse, sorry, is 1. We're living in a circle right now, right? Because I know where we're going is the shortest, fastest answer. Because it doesn't really matter how long that is. I can just get that ratio going there, and but we'll almost always be multiplying the hypotenuse length times the cosine or the sine, depending which side I want of that angle, to get either how far I've traveled out or how far up I've traveled. One of those two things. Because those are usually the things we're interested in. We're usually either interested in an opposite side or an adjacent side. We are. Just know that that happens a lot in construction, in architecture, in physics, and math, like everywhere. All right, so my theta is pi over 8, right? I did not color code A plus B plus C there. That is only going to aggravate me later on. This whole screen's getting ready to jump on you. See if I can actually click it. There we go. All right, now I feel better about life, right? So there we are. We have that. Come on. There we go. So then I put that in my calculator, and I get 10 times cosine of pi over 8 equals 9.2387, blah, 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 right? All sounds great. I want to keep that number. I want to store it for safekeeping. I'm going to label it F because that's the next letter. I already have A, B, C, and D down here. And I don't like storing numbers. I don't like storing things as E because in my brain, E is a number. You were supposed to see that and learn to like it a little bit or hate it in Algebra 2. And then you were supposed to see that, know that, make it part of your soul in Chapter 3. I was not with you in Chapter 3, so I don't know that that happened, but I'm going to pretend that it happened. And then I've also found out through the years that a lot of people don't share my love for the Euler's number that I have. So they may not have made you enjoy the fact that E is a number. It's my favorite number, by the way. If you ever want, like, if I ever become part of a trivia problem, I won't. But if I ever do, E is my favorite number, naturally. All right. So I'm gonna take that. I'm gonna skip E, and I'm gonna store it as F in my calculator. Grab your calculator. I'm gonna do it real fast just for you. Don't freak out. Grab my calculator. I don't know why it looks like it's pixelated here. That's great. 10 cosine pi over 8, close parentheses, store F alpha F. Oh, hold on. Did not mean. Hit alpha, then hit F. I'm over here hitting my shortcut keys on my calculator. I wasn't supposed to show you them yet. All right. We'll talk about that later on. So that right there becomes 9.238. I store it as F so that my calculator keeps it there forever because it wants it. All right. And now I have that. I'm not done. I'm just going to hold on to it because honestly, I don't really want to keep track of it. It's there. It's beautiful. I have it if I ever need it. Right. So I have that piece out of my brain. It's used. I have it. The calculator's kept it, so I don't need to write it down. because I just made a note that it was F. All right. Now, I'm done with that triangle. Yay. I'm ready to go on to the next one. All right. Then the second piece, the second cutting line, whatever, goes right through there. Right? I don't even really need this anymore. Yeah, I'll leave it there. It goes right through there. So now my cosine, right? Cosine of this side is just, that bottom side is just a plus b over 10, which is still my hypotenuse, right? Multiply both sides by 10, so I get that bottom side there. That's a plus b. Now, for theta, in case you don't see this right away, because a lot of people told me that they had questions about, I don't know what I'm clicking on. They had issues seeing radians naturally and all that stuff. So I will slowly go through the radians a little bit, right? This is the second triangle, so our theta has two of those pieces. Remember, each piece had a size of pi over 8. So there were 2 pi over 8s in this bigger angle here, right? So pi over 8 plus pi over 8 is 2 pi over 8, which reduces to pi over 4, right? I'm going to do this a little bit faster in the calculator, right? Go to my calculator, store that value as G in the calculator, because that's the letter after F. You will get this, and just so that you guys don't think I'm cheating you, I'm going to go ahead and bring my calculator in, even though I wasn't planning on it. Here we are. Boom. Right? 10 cosine pi over 4, close parentheses, store for G. I have an auto button to go to the alphabet thing, but you'll hit alpha G. If I make that bigger, is it going to be less pixelated? That's a little bit better, right? 7 point whatever, 707. Oh, by the way, if you're not getting the same answers as me when you do this in your calculator, it's because you have to hit mode and make sure you're in radians right there. Because if you look and you're over here in degrees, right, not going to work. You're going to get the very wrong answers. Go to the radians. Make sure your answer makes sense. All right. So that's G. Boom. Now we have process. That's the second piece. Watch. Again, I didn't say this was fast. This is going to be smooth. It's going to get smoother and smoother. So let's move all that up. Ah, not the background. Oh, man. All right. Move all that out of the way. Right. Well, now we're done with that triangle. So let's look at the next one, the last important one, over here, right? Now, that one, its cosine is just section A over 10, right? Multiply both sides by 10 to get A by itself, because that's what I'm looking for, right? 10 times that. This is our third triangle, so our theta has 3 pieces. So 10 times the cosine of pi over 8 plus pi over 8 plus pi over 8. That is 3 pi over 8s, right? And I'm going to store that as A this time. All right, in the calculator, exact same steps. 10 cosine, notice I don't even need multiplication there. That's pretty cool. 3 pi over 8, store for A, 3.82. All right, I'll let you see me do it. Clear that out. 10 cosine pi over, not pi, 3 pi over 8, close parentheses, store for A. Alpha A is right there. Here. Alpha A. Enter. 3.8268, blah, 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 34324, all the good stuff. It doesn't really stop there. All right. So now I have that in there as well. And that's it. That's all my big calculations. That's the using the trig. I found it. I found the distance to A, found the distance from here to A plus B, and I found the distance from here to A plus B plus C, and I know that whole thing's 10. That's all the math stuff I need. Well, I mean, when I say math, I'm not talking like basic arithmetic. Let's move all this stuff out of the way now. We don't even need that. We don't need that. I'm going to keep that radius as 10 up there still. So now let's check out what, was it Alan came up with before Alicia came in to save the day? Right? Well, Alan said A was 3.827, remember? And ours was 3.82683, whatever. That rounds to 3.827. So, all right, he's rounded to 3 digits. That's fine. So, here's where I get to write with my finger. No, with my mouse pad. So A looks good, right? So now we go to find B, right? Well, we know what A plus B is, right? That was stored as G. Remember? That was this guy that was stored as G. And that's from here all the way out. But we only want from here to there. So we're going to take that A that I had, we're going to subtract G from it, which is really cool in your calculator with these stored numbers in here. I'm just going to go over here and I'm going to hit G minus A and hit enter. And that's 3.244, which is the same thing he had. Well, look at that, Alan. You got 2 in a row. I swear if I forgot these people's names and it wasn't Alicia and Alan, I'm going to be embarrassed. But let's pause real quick. The doorbell just rang. All right, sorry about that. I am back. My children are talking now, so I apologize because they're not going to stop. Mackie, you feel my pain. All right, so I've gotten that one. Now I'm on to the third triangle, right? And this one, I don't have to worry about that one anymore. This one is that last piece minus that second one. So remember, this guy here was labeled F, and this one was labeled G. So now it's just F minus G. So I'm going to grab my calculator, and I'm going to go F minus G. Hit enter. Well, oh, by the way, I didn't check. I said that B was right, and B wasn't right. I have the answer up there. He was close, 3.244, not 3.4. All right, I'm assuming now that everyone was laughing at me, and I didn't realize it, because I looked and said, oh yeah, he got that right, because I was just ready for it to be right. So that one's wrong. He was off by 1/10. That was probably, I'm going to give him credit and just say he just wrote it down wrong. If not, you guys have used that excuse, because otherwise, how would he be so close to be off by 1/10? Unless he just can't measure. It also matters on how he was doing it, his method-wise. So F minus G is 2.168. Oh, look, this is why I think he was off by, he just wrote something down wrong, because he's off by 1/10 again. The same, well, except here he was 1/10 too long, now he's 1/10 too short. If you think about that, you can see how that happens. All right, so that's now C, and then D, right? Well, that is just the whole 10 feet minus that gray triangle, which was F. So now I'll just take 10 minus F, and that is 0.761. So that one he got correct. Y'all see that? How it's all just a big setup thing? Once you get it set up and you can get those triangles going and you get your angles right. You get the angles right, you get your triangles set up, you can just store numbers, and then it's smooth. You end up having a process to where you can just go bang, 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 one after the other. And that's it. And that took way longer than it probably needed to. I apologize, but I get talking sometimes. All right, let me get done before 20 minutes. Y'all have a good one. Have fun. See you.